So they gave you the m1 and m2 and theta, and they ask you to find the acceleration. Now, based on the fact that m2 is bigger than m1, I'm going to assume that it's going to go that direction. Now, that's just an assumption. If I'm wrong, the acceleration is going to turn out to be negative, and then I'm going to have to sort of adjust things. But that's what I'm going to assume. So now I'm going to draw my free body diagrams. So for m number 1, I've got m1g pointing downward. I have the normal force perpendicular to the surface, and I've got the tension from the string, like that. There's no friction because it says in the problem that the surface here is frictionless. For m2, I have just m2g going down and the tension going up. It's the same tension because it's the same string, and that's all I have. So now I can start writing equations. For this diagram here, I can only do one equation in the y direction. I got these two force vectors, so I put them in here. T positive because it's up, m2g negative because it's down. And that's going to be equal to minus m2a. It's not 0 because I'm trying to calculate the acceleration, so I know it's accelerating. And I made it negative because I think this one's going to go down. Then we come over here and we get ready to do x and y equations for this one. I'm going to draw my axes slanted with the y-axis through the normal force and the x-axis perpendicular to that in the direction of motion. So then I see that I have two vectors that are flat on axes, but this mg vector here is slantways, so I need to find the angle between that and the nearest x-axis. That's this angle here. And I see that that's this angle up here. So I'm going to call it 90 minus theta. But you know what your theta is, so just call it the number. So then I'm going to write my equations. In the x direction, I've got the tension going to the right, so that's positive. The mg, as far as x is concerned, mg is negative, so that's minus m1g cosine, because it's x, 90 minus theta. Now remember, you're just going to put the number in here. And that's going to be equal to, well, not 0, because we know that this object's going to accelerate. And we think about it, it's going to go this way, which is to the right, and that's positive. So I'm going to call that positive m1a. In the y direction, I have the normal force flat on the axis, and the y component of m1g. So I had m1g cosine 90 minus theta in one equation, so I have m1g sine 90 minus theta in the other equation. And this one's equal to 0 because it's not going to move in and out of the surface. So the question asked for the acceleration. The acceleration is in both of these equations, and so I'm going to be pessimistic and assume I have to use the complicated one. So there's my acceleration. I like it. I have this mass, so I'm happy about that. I know what theta is, so that's good. I know gravity. I know the other mass, but oh, I don't know the tension. So I need to go to another equation to find tension. So here it is up here, another equation. So I can solve this t equals, because I'm trying to get rid of that tension. So I see here that t equals m2g minus m2a. That's just adding m2g to both sides. So I'm going to take this guy and stick it in there and get a new equation, m2g minus m2a minus m1g cosine 90 minus theta equals m1a. And I'm really happy about this equation because I know the masses, I know gravity, I know theta, and I want to find the acceleration, so there's nothing in here I don't like. So my next thing is to get everybody with acceleration on one side and everybody without acceleration on the other side, which means I'm going to move this guy over there by adding. So now my equation is going to say m2g minus m1g cosine 90 minus theta equals m1a plus m2a. The next step is to factor a parentheses. I'm factoring out the thing I'm looking for. m1 plus m2 equals the same thing. And then I just divide by this and I get the acceleration equal to m2g minus m1g cosine 90 minus theta over m1 plus m2. And this makes sense because we expect the total moving mass to be in the denominator, and there it is. We expect an explanation for the motion to be in the numerator. So this says that the whole system is being sped up by m2g. Well, that makes sense. That's what's going down. That's speeding it up. And it's being slowed down by the along the plane component of the other mass. So that's saying that this is being slowed down by the fact that this is being pulled up the hill. And that makes sense. So we plug numbers in there, and as long as this comes out positive, then we did this right, and you can choose down for the answer to part B. Then in part C, it asks you to calculate the tension. Well, we have an equation right here that we used earlier to eliminate tension from another equation. So you could just plug numbers into that. The tension, according to that, is equal to m2 parentheses g minus a. And now that you know a, it's easy to plug into this and find the tension.